So as we begin our study of graphics, we need to think about how first to represent colors. All colors on our computer are going to be represented as having a certain amount of red, a certain amount of green, and a certain amount of blue. This is often abbreviated RGB for red, green, and blue. Each component of the color, each red, green, or blue value, can be anywhere from 0 as a minimum to 255 as a maximum. So we represent white by having the most amount of red, green, and blue, each having the value 255. We represent black by having the least amount of red, green, and blue, each component being 0. We make a new color by using the color constructor that Java has provided for us, and the three parameters that it accepts are exactly the red, the green, and the blue values you wish to have in your color. So if you want to make a color that represents white, you would say new color 255, 255, 255. But because some colors are used so frequently, Java has also provided built-in colors such as color.white, color.black, color.green, and so on. For standard colors, you'll probably find a color that's available that you could already use. To make your own custom color, simply call for a new color by passing the amount of red, green, and blue that you wish. The next thing to talk about is the coordinate system in which we're going to be plotting points, lines, circles, and so on. In the Sedgwick API, the default coordinate system has the 0, 0 point at the extreme lower left, which for those of us who've studied or plotted functions is fairly common in math. The upper right point is 1, 1. So along the x-axis, we can vary from 0 to 1, and on the y-axis, also from 0 to 1. So as we specify coordinates, unless we make a change to the coordinate system, all the points that we specify would have to be in the 0, 1 to 0, 1 two-dimensional coordinate space. If you try to put a point down or any kind of object outside that space, it simply won't be shown. It's as if it was clipped away. Let's take a look at the API that Sedgwick offers for doing graphics. We have most of the objects we'd like to represent directly implemented for us. For example, to draw a line, we specify 4 coordinates, the first 2 being the xy pair of one end of the line, the last 2 being the xy coordinate pair of the other end of the line. A point is simply specified by specifying its x and y coordinate, and calling these methods will put a point down on the canvas and you'll see it appear. Drawing a line, we'll put a line on the canvas, you'll see that appear as well. For the other objects that we want to place onto the canvas, the notion of the x and y coordinate is actually the center of that object. That's not true in traditional graphics, but it is true in Sedgwick's API. For example, to put some text on the screen, we specify the xy coordinates, which are the center of where the text will appear, and then the string is equally balanced left and right of that particular point. For a circle, we specify the center of the circle along with its radius. For a rectangle, we specify the center of the rectangle and its horizontal dimension and its vertical dimension separately. So looking through this API, you'll get a good feeling for what you can produce on the canvas. You have the ability to produce filled shapes, including circles and rectangles. There's also the ability, using an array of points, to specify either unfilled polygons or completely filled polygons. We can change the color of what we do by calling set pen color and providing colors as have been previously described. And the analogy here is that it's like you're picking up a marker or a crayon of the specific color, and everything you draw after that is in that color. And then if you change pen color, you're picking up a new pen, and everything you draw after that is in that particular color. So the color that you change to sticks until you change it to some other color. Finally, if you don't like the coordinate system that we have here, you can change the x scale or the y scale by using the appropriate methods.